Okay, I got a great question about use the Pythagorean identity skill to solve these problems. So Khan says that the angle of theta sub 1 is located in quadrant 4, and we know that sine of theta sub 1 is negative 10 over 13. Okay, and we're just asked to express the exact value of cosine at that location. Okay. Um, so what we're going to do here is remember SOHCAHTOA. You've probably heard that little, I hope you've heard that little mnemonic. It means that sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So since sine is opposite over hypotenuse, we can draw up this triangle. Now we're just going to ignore the fact that sine is negative, right? When you're just dealing with the right triangle trigonometry, you just kind of, all the values are linked, so they're positive. Now the unit circle, you can have, sine and cosine be negative and everything. So really what I do is I go to right triangle trigonometry, and then I go back at the end and I figure out what sine, or sorry, not sine like the function, but what if it should be plus or minus, okay? If it's negative or positive, okay? So let's draw the triangle. And I've done this, I think, here. Okay, so since sine is opposite over hypotenuse, right? And this, if this would be theta, right? This would be opposite, which is 10, and over hypotenuse, which is 13. And I don't know the adjacent. And that's really what I need to figure out the cosine, because the cosine of theta is really the adjacent over the hypotenuse. But thanks to the Pythagorean theorem, I can figure this out, right? This is a right triangle. I didn't draw on the little elbow here to indicate that, but it's a right triangle. So I just go and set it up. 10 squared plus whatever the adjacent is squared is equal to 13 squared. Here I just replaced it with x, so we didn't have to have an equation with a question mark in it. And I solve this down until I get that x is equal to the square root of 69. Okay, now of course I could get a decimal approximation for that, but the problem asks us for an exact solution, not a approximate solution. So then the cosine is just the adjacent over the hypotenuse. So if this right here is equal to the square root of 69, the adjacent over the hypotenuse is the square root of 69 over 13. Okay. Now we want to think about the sine. Okay. Now we know that we're told that the angle's in the fourth quadrant, and we just need to think, well, in the fourth quadrant, are all the values for cosine positive or negative? Well, on the unit circle, right, the cosine is always associated with the x value, right? So in the first and the fourth quadrant, cosine is always positive. So we're going to not add a negative and just keep it positive. Keep it at a square root of 69 over 13. Okay. Some problems, if they told us it was in a different quadrant, right? Like if it was in the third quadrant, we would have to make it negative square root of 69 over 13. Okay, let's see if we are right. Okay, got that good sound. So that's how I would do this problem.